Okay, let's do the complicated problems now. So if we had something like this, sine x is equal to cosine x. So I know the temptation is to just say, well, I know we can do this intuitively. What's the only time sine and cosine would actually be the same thing? And it does happen twice. But right now, if you can figure that out intuitively, great. But they're not always going to be something nice and easy like this. But so what we would do is we'd say, well, I really need to do a substitution. But if I do a substitution, I'm sorry, I don't have anything to substitute right now because there's no relationship. There's nothing I can sub for sine that's equal to cosine. So what we can do is square both sides. So then if we square both sides, then we can sub for either one of these. And we've already done a problem like this in one of the previous videos. So we can do something just real easy like this and say, oh yeah, now if I bring the sine over here, so I have 2 sine square minus 1 is equal to 0. We could do this a couple of different ways. Sine square is equal to 1/2. So sine is equal to plus or minus √2/2, because we've already done this a couple of times, okay? So once again, we get all the pi over 4s. Yay, it's all the pi over 4s. But wait a second, I said that there should only be 2 solutions. There should only be 2 solutions. All right, here's the problem. When you square both sides, you introduce possible extraneous solutions. It's like if you said, well, sine and cosine of pi over 4, they're both positive √2. But see, at 3 pi over 4, one's positive and one's negative. So that doesn't work. 7 pi over 4, one's positive, one's negative. That doesn't work. But 5 pi over 4, they're both negative. So the 2 solutions are only actually pi over 4 and 5 pi over 4. So that's an issue. When you square both sides, you introduce possible extraneous solutions. I probably should have done this first. Let's talk about that real quick. If you've got x equals 1, there's one solution to that problem. If I square both sides, I have x squared is equal to 1. Now there's 2 solutions. Now x could be plus or minus 1. So the original statement was x equals 1. There's only one solution. But if I square both sides, I introduced a possible extraneous solution. So that's why we can't, or that's why when we square both sides, we have to check for extraneous solutions. And I probably am going to spell this wrong because you know I can't spell. Extraneous solutions. When we square both sides, we introduce possible extraneous solutions. All right, what about a situation like this? Okay, because you're thinking, boy, it sure looks like I ought to be able to just substitute for one of them. Unfortunately, there is no relationship here and here. I can't just sub something for secant plus 1. But if it was secant square minus 1, I could do something, or tan square, I could substitute in something. So once again, we've got to make it squares so that we can do a substitution. And then once again, oh my gosh, algebra 1, I'm going to write this out, even though once we start doing this in class, I'm not going to write this out every time. See, we've got to foil this. So secant square plus 2 secant plus 1 is equal to tan squared. And I know you're thinking, well, okay, these are getting a little more complicated now. So in this case, the substitution, since these guys are all secants, I can make this into a secant, since that's secant to the first. So I can make this into a tan square plus 1, but then I'd still have a secant to the first. So I think the thing to do here is replace that tan square with secant square minus 1. I know these didn't seem that bad. Now all of a sudden they're getting funkier. So we're going to add secant square to both sides. And we're going to add 1 to both sides. Something like this. Does that seem reasonable? Okay, I feel like I just made I just did. I made a humongous mistake right here, didn't I? I just made a humongous mistake. See, I'm supposed to subtract secant square minus secant square. So that is actually gone. Because when I was looking at it, I was thinking, wait a second, that doesn't have a solution. But see, this is what we're always talking about. We always have careless mistakes. That's what we got to watch out for. So now I've just got, secant x is equal to -1. Well, when does secant equal to -1? Well, let me see. The only time secant is equal to -1 is, everybody ready? Pi. Okay, so secant's -1 at pi. But then we really need to check our solutions. So if I said secant pi, because we squared both sides, I need to check my solutions. Okay, so let me see. That would be -1 plus 1. Okay, what's tan of pi? And this is where everybody gets upset. Oh no, I gotta remember my unit circle again. So tan of pi would be -1 comma 0. So tangent of pi would be 0. Oh yeah, so this checks. So that does check. That is the solution. Okay. So when we're doing squaring both sides, we are going to have to check both sides. I mean, we're going to have to check our solutions. We're going to have to watch out for extraneous. Okay. All right. We'll do the calculator problems next.